Hello everyone. I'm Digaamber Dhamija, and this is my research capstone project on a deep learning based tracking and counting system. To introduce the topic, first of all, video surveillance cameras have a lot of advantages. They can prevent threats in workplaces such as theft and mishandling of goods. They can also be used to monitor scenarios and activities and maintain records. However, their potential is not fully realized when they are used as simple recording devices. With the advent of IoT technology and the availability of low cost developmental boards with considerable graphics processing, it is time to add additional processing layers over this technology to serve its users better. Therefore, a clean, automatic, deep learning based system is proposed to detect, recognize, and track the number of times each person has appeared in a frame. The ideas presented here can be directly employed in a variety of applications. So, this is the pipeline that was used in the project. The first was detection and localization stage, the second was recognition, and the third was counting. Let's go over each of these stages one by one. So the detection stage. This stage detects and extracts the crops of the faces present in an image. For this, the YOLO V5 algorithm was used, which is a state-of-the-art object detection algorithm, and it offers the following model sizes with these parameters. Uh, in this project, the YOLO V5S and YOLO V5M models were trained on the wider face dataset. Now, the wider face dataset is a face detection dataset. It consists of a large number of images and with high degree of variability in scale and pose. Therefore, it provides an ideal representation of what one might encounter in a real-time CCTV footage, and thus it will help us to train a robust model for face detection. So these are the training results of the YOLO V5 algorithm. This is the MAP score at zero point 0.5 IOU, and this is the MAP score at zero point 0.5 to 0.95 IOU. These are the precision and recall scores. The orange curves represent the YOLO V5S model, and the blue curves represent the YOLO V5M model. So now to move over the recognition stage. In this stage, a pre-trained PyTorch implementation of the FaceNet algorithm was used. This implementation uses the Inception ResNet V1 model trained on the VGG Phase 2 dataset. The fundamental approach to the recognition task is to extract an embedding for a face image. For each crop of a face, its embedding is extracted and its Euclidean distance is compared with a set of stored ones. If the embedding with the lowest distance has a distance less than a predefined threshold, we classify it as known. If the distance is greater than that threshold, we match and store it in a separate dataset consisting of unknown faces. The result is that the system is able to recognize both known and also able to keep a track of the unknown faces. Now, various Python APIs have also been built to add and modify the dataset of embeddings. Now, the counting algorithm. For this step, two variables are associated for each recorded person: presence and count. Whenever a person is seen in the frame, the presence variable is implemented. In real time settings, however, this algorithm is working on a large number of frames per second. For instance, a person might spend 5 to 10 seconds from walking from one corner of a frame to the another. In If a video feed is of 30 frames per second, then this would update the presence 30 into 10, which is 300 times. So to mitigate this, we divide the time into windows of 10 seconds. This is termed as a reset threshold, which is a modifiable parameter. At the window's end, we reset the presence of a person and increment the count if the presence is a non-zero value. Finally, we store this count in a separate dataset along with the other attributes of the person. So this is an image of the real-time inference of our system. The D here represents distance, P represents the presence, and C represents the count. This is for a known individual, and this is for an unknown individual. A simulation was also designed using the labeled faces in the wild dataset to generate a sample of counts and to demonstrate how these counts can be analyzed. Uh, for the simulation detections, the detection stage was bypassed and randomly generated images from the labeled faces in the wild dataset were directly passed to the recognition stage and to the counting stage. An efficient deployment of the system is also proposed, which consists of three aspects: cameras, consolidator, and a cloud system. So the cameras pass the image frames to the consolidator, which is a local system. The consolidator runs the detection algorithm and calculates the embeddings for the detected faces. These embeddings are sent to the cloud, uh, which records the counts of the individual and updates them in the dataset. So this was my capstone research capstone project. Thank you for your attention.